All right, thanks for joining us watching this video. It's really important that you watch, and because I promise you watching this titration video is going to make your titration experience so much more pleasant because you're going to have some sort of idea as to what's going on. Titrations are very, very big in AP Chemistry. This is our very first one, so we're going to only do 2 trials. We're going to give you a day for each trial, so I'm hoping to alleviate your stress level a little bit, but I can't stress to you how important it is to understand what's going on in titrations as well as know how to use the equipment. So the first titration that we are going to do is we're going to find the concentration of a strong acid. In this particular lab, which we're starting, it's actually a 2-part lab with 2 different methods. One is the titration, and the other is a gravimetric method, where we're going to pipette and create a precipitate and use good old-fashioned stoichiometry to determine concentration. That's easy. What I want to focus on right now is the actual titration itself. So your job is going to be to find the concentration of H2SO4. This is going to be your unknown. This is what you are looking for the concentration of. And we're titrating it against a 0.25 molar solution of sodium hydroxide. So we know that our products, of course, are going to be a salt and water. So our water is water, and our salt is, in this case, sodium sulfate. Okay, and we know that this is a strong titration, which is going to have more meaning later when we do weak strong titrations. So just keep that in mind. This first one is strong. And so if we balance, we'd need 2 sodiums and we'd need 2 waters, and I believe that's balanced. So the point of the titration is going to be to find enough information where you can figure out stoichiometrically how many moles of sulfuric acid reacted with a given amount of sodium hydroxide. So what do you take from the titration? You're going to figure out how many mils of this known concentration of sodium hydroxide is required to reach something called the equivalence point. Once we know how many mils we need to neutralize a certain volume, and in this case you're going to be putting 10 mils of acid into a little beaker, and then you're going to titrate out of a burette, and you're going to figure out how many mils you need. Once we get this value, this mil value, we can follow the steps we talked about in class. First, to find the moles of the known. Well, that sodium hydroxide is our known. We can find moles from molarity in liters really easily, right? And then the next step is to find the moles of the unknown, and that's through stoichiometry. We're going to stoich on over to find moles, and once we know the moles of the known, we can then find the molarity by taking those moles that we calculated through stoichiometry and dividing it by the 0.01 liters, or the 10 mils that we used when we started the titration. So that's kind of the big picture of what's going on and what we're going to have to do. So again, our goal from the titration is to figure out how many mils of that known we need. Equipment. What equipment do we need? So you guys are going to be using lots of equipment this time. You're going to have a ring stand. And on that ring stand, you see right here is a ring stand, you're going to have a burette holder. The burette holder is made to hold a burette. To actually get the burette in there, you're going to squeeze these 2 little clamps down, and it's going to open and make a little space for you to insert the burette. It's kind of going to be set up for you, but you will have to be able to remove the burette, take it down, and put it back up as you fill it. So that's definitely something you're going to get to play with. And you get to use, and everybody is so excited about using these in AP Chemistry, are magnetic stirrers. In order to get a smooth pH curve, we have to have the solution constantly stirring. Stir, 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 stir. So this box right here has a magnet that turns. And so in your solution, you're going to put this thing called a stir bar. And the stir bar is going to stir the solution when you turn this box on. Because then once the magnet turns, it's going to attract the stir bar and make it turn just as if the magnet's turning the same. So it's basically stirring it for you. It's the lazy man's piece of equipment. No, it's actually important because you need a constant flow around your pH sensor in order to get a smooth curve. Okay, so what else are we going to be using? Well, this is a pH titration, so we're going to have to use a pH sensor. This is a pH sensor, and we're going to attach it to the LabQuest. You guys used LabQuest in the last lab with the colorimeter. Now we're just changing the sensor we are using. It's very important for you to realize that this sensor has a glass tip that has a membrane. It's a porous glass tip, and this porous tip will allow ions to flow in and out of it, and that's how the pH is calculated. That glass tip is fragile. So it is housed in this plastic case. You have to unscrew. If you can see it there, there's a little top. The top stays on the actual pH sensor, and you unscrew the bottle part. So this bottle comes off, and you leave the plastic top piece on. And that's what you connect here. And so you put the pH sensor here with the plastic top holding the pH sensor. Okay, and I'm going to show you the full setup in a minute, but that's going to hold, this utility clamp will hold the pH sensor in your solution as you're titrating. And then here, this is a funnel. You're going to have it on top of your burette. Please use it to fill your burette so you don't spill base everywhere. Okay, so in terms of setup, this is a little bit different than the clamp that's in the picture that we're actually using, but here's a burette clamp. There's many kinds of burette clamps. It's going to hold the burette. You want the burette to be over the actual beaker. That's crucial. And you want the stir rod to be in the middle of the beaker. So when you're starting your setup, first get the beaker onto the stir plate and make sure the beaker is centered. Then you can orient your ring stand so it's an appropriate distance. So the utility clamp here holding your pH sensor goes into the beaker, as well as having space for this burette. So you can see it's a pretty tight squeeze. You're going to have your burette, and your burette is hovering above because you can do drops from a distance. Your pH sensor has to be in the solution the whole time from the beginning, okay? And then you got this stir bar down here that has to be centered on the plate, stirring and stirring and stirring. So the first step is going to be to pipette your acid into the beaker. That's going to be a 10 ml volumetric pipette. And you know how to fill a pipette with those green, remember the green pipette fillers that you've used for the measurement lab? Now you get to use it again with a different kind of pipette. Now, when you pipette the 10 mils into your beaker, you're going to be like, oh my gosh, that's barely any liquid. It's going to barely cover your stir rod. And you're like, what do we do? Well, you're just going to take your DI water bottle, open it up, and dump some water in there to give it some volume. That water does not change how many H+ ions you put in from the acid. That water does not change how many sulfuric acid molecules there are. Okay, so it doesn't matter how much water you add. The point is to add enough water to cover your pH sensor that has to stay moist all the time. Your pH sensor is either in the storage bottle or in a solution. You never let it sit and dry out, because if it dries out, it ruins it. Okay, so you add enough water, DI water. It has to be DI because we don't want to mess with the pH. Add that to cover the pH sensor, and then you start the stirring process. So add enough water, place the beaker on a stirrer. We talked about that. Remove the probe from the storage solution. Okay, then you're going to want to rinse it really quick with your DI water to make sure to get all the salt solution off of it. And then put the sensor into the solution. If it's not tall enough, if the solution isn't high enough, you can either drop the utility clamp down a little bit. These move. This stuff you can move to fit appropriate heights. or you can add a little more water. Either way, you got to get that sensor submerged. Start your stir. Make sure your stir bar is not hitting the pH sensor because it could break it. And these, my friends, cost $125. So we do not want to break these because we're poor. Even though we're Westlake, we don't have a big budget. So let's really take care of our equipment. We're going to make sure that it doesn't hit the sensor as it's going. And we also we want to make sure it's not splashing stuff out. Okay? If our thing is splashing out solution, what are we doing? We're losing acid, right? And if we lose acid, our experiment will take less base to neutralize, and so it'll come out that our acid isn't as concentrated as it really is. So losing acid here is bad. So we want to make sure to nice and gently stir so stuff doesn't jump out. So then, while one person is working on all that, another person can be rinsing and filling the burette. You want to rinse the burette a few times by tilting it and put a few mils in, tilt it, roll it around, let some base run out through the tip, and then fill it up, and then attach it to the burette clamp and put it in an appropriate way so it's hovering over your liquid. You want to make sure your burette, remember they read backwards, the 0 is up here, so you want your meniscus to be right at the 0. Every time you do a titration, I want you to start at 0. These pH titrations, you have to start at 0, okay? So then you're going to start titrating. And as you titrate, you're slowly going to add the base to the acid and record in the LabQuest at certain increments how much base you've added. So let's say, and the way it works in the LabQuest, you'll have to read your procedural instructions. I don't know the exact order, but you're going to have your pH sensor loop into your liquid, right? And it's going to read initially a certain pH. You're going to enter that with 0 mils of base added. And then as you continue, you're going to add maybe a half a mil. And then you're going to hit the keep button on your LabQuest and type in how many mils you've added. So every time you hit keep, the LabQuest records the pH and you enter the volume you added. Now, it's a cumulative volume. You don't subtract or anything. You literally just enter where it is on the burette. So if this is 1, 2, 3, 4 mils. And you're going to enter stuff in smaller increments in this. I'm just trying to make a point that if you stop there and hit keep, you enter 1 mil. And then the next time you stop here, you enter 2 because it's total volume you dispensed. You don't say, oh, I added another one and hit 1 again. You enter what you read. So if you then go down to here for the third point, you're going to enter 4. So you literally just enter into the LabQuest how many mils you have dispensed. That's going to create this really cool graph. I'll be walking around. You want to collect a lot of data points. The more data points you collect, the better off you'll be. That's why you have an entire hour to collect these data points, an entire period. So we get really ugly curves if we only have 4 or 5 points. So what you need to watch for is this sharp rise. This sharp rise is where we're going to get our important information. Okay? It's the place with the highest inflection. It is in the middle of the sharp rise is our equivalence point. I want you to notice something. Since this is a strong, strong acid base, when it's totally 100% neutralized, what is our pH? It should be 7, right? So notice that at the middle of this sharp rise, the pH is 7. That's what we're looking for. And here is where we will find the mils we need to figure out the moles of our known. So this is all we're doing. We're making this curve. We're going to the middle of the sharp rise, called the equivalence point. This equivalence point is where the moles of our base that we're adding equals to the moles of the acid in the actual beaker. So we are looking for these mils. That's the whole point. Once we get these mils, we're done. Once we know the mils, so you're going to titrate, and you're going to go fairly quick, but when you start to see a sharp rise in pH at this sharp incline, I want you to slow down and maybe do a drop at a time until you get a pH that's leveled out. Once you do 4 or 5 increments and the pH is not changing anymore, you can stop the titration. So you want to see this curve. And I'll be there to help you, but remember, we want as many points as possible, and we want a really distinctive sharp rise. You're going to do 2 trials. Your first trial may be a trash trial, and that's okay. You might just want to use your second, but we'll see what happens when we actually run the experiments. So as far as calculations go, this is exactly what we did in class. To find the molarity of the acid, you first find the mils of base at the equivalence point. So that's the mils of base, remember, in the middle of that sharp rise. So you're going to take those mils, you're going to use those along with the molarity of that base, which was 0.25 molar, and you're going to find moles of the base. Okay? Now, moles of base equals moles of acid, but it's based on the stoichiometry. So what you do here is you use that balanced equation and stoich on over from the base, stoich on over to the acid in the reactants in order to figure out how many moles of acid. So once we find our moles of acid, we take that and we divide by the volume of acid we used originally, which was that 10 ml pipette, right? So that's 0.0100 liters. And that will give you the molarity. So you're going to do 2 trials, one trial on one day and the second trial on the other, because I want you to have time. And then after this, I'm going to expect you to be able to do 2 or 3 of these in every period. And you'll get experience and you're going to become masters. Masters at titrations. I definitely promise you that. So I had a video here. YouTube's being crazy today. If you're interested, you can pause and type all of this if you're curious and would like to see it. It's a group of high school students doing a little bit of a titration and using the same equipment we use. So if you feel a little overwhelmed, like you don't know what this stuff looks like and you don't know what you're going to do, go ahead and take a minute and type all that into your queue and look it up, watch it. And then finally, last little slide. Now get ready to titrate. Do your PreLab and come with your game face on. It will be crazy. Miss Rozier and I are stressed on these days because we know how many points you really need to take. And you got to have a sense of urgency. You've got to do teamwork. When one person's cleaning up, the other person needs to be filling the burette. You got to work together and you got to work hard the whole period. Day 2 will be a lot better. So be ready. Have a great evening.